All right, so we are going to start chapter 5 today, and we're going to spend the next few weeks in chapter 5. If memory serves me correct, we will test on chapter 5 sometime in November. Yes, we will test on chapter 5. Right now I have us slated for a chapter 5 test on November 7th, okay, which is a Tuesday. So you got this week, there is a formative this week, okay. Next week, there is a formative next week. Then you got a 3-day week, okay, and there's a quiz that week. And then you've got a full week, and then on the Tuesday of that following week is your test.
What do you do if you're not here on Friday?
This Friday?
Yes.
Then we'll talk when it gets closer to Friday.
Okay.
Okay?
I will not be here on Wednesday either.
Okay. Alright? Ready? So, chapter 5 deals with polynomials and polynomial functions and solving them for zeros and finding rational zeros and using some division and factoring and a bunch of great math. Love this stuff. Okay? But it also starts with a refresher on your exponent properties. Now, for most of you in the room, this should be your 4th go-around with your exponent rules, because you did them in Algebra 1, you did them in Algebra 2, and you did them in Geometry. Okay? So this should be the 4th trip around this block. Okay? So, remembering that x to the 4th power means x times x times x times x. Okay? Let's see what you remember. Okay? So try those 6 problems. How many people got all 6 of them? Good job. 5, 4, 3, 2, 1, none? Okay. All right. Let's talk about these rules now. Okay. Here we go. So, properties of exponents. If I have the same base and each of them have an exponent, what do I do with the exponents? Add the exponents. So the base here stays the same, but I add the exponents. Okay? When I'm multiplying with the same base, I add the exponents. Okay? Power to a power. So I've got a to the m power to the nth power. Power to a power here. What do I do with the exponents? Multiply them. Okay. When I'm dividing, rip the same base.
subtract them.
Top minus bottom. Do I like negative exponents? No, don't like it. So we have to move that whole thing to the bottom to make it positive. Or, conversely, if it's already on the bottom, I move it to the top to make it have a positive exponent. Okay. Exponent rule number 5, anything to the 0 power is 1. Okay. And number 6 is just kind of a cluster. Okay. When you have multiple things inside of your exponent, you distribute to the exponents, and so that would be A times B to the MR power times C to the NR power. Now, if there is an addition sign somewhere in this parentheses, then this rule does not apply. This rule only applies if it's multiplication inside the parentheses. Okay? We'll get to if there's an addition or a subtraction sign inside the parentheses a little bit later on this week. Okay? So, let's go back and let's try some more of these type of problems. So, try those two on your own. Apply those properties that we just went over. So, this 3 would have to go into there, and into there. So this becomes 2 cubed x to the 9th, y to the 6th. So let's write that as 8 x to the 9th, y to the 6th. Agree with me on that one? I could write this one as x to the 7th over x cubed, make them both positive, right? Or I could say this is x to the negative 3 minus negative 7 power. Okay? Either way, I get x to the 4th power. All good in said hood? Okay. 3 more to try, maybe. There they are. So, on this one, it's like 2 times negative 3. And then x cubed times x squared, and then y to the negative 4th times y to the negative 2. So that's going to be negative 6 times x to the 5th times y to the negative 6th. So in the end, we can go negative 6x to the 5th over y to the 6th. In this one, it would be like 4 to the negative third, m to the positive sixth, n to the negative 12th. Okay? So this one would be like 1 over 64. This one would be like m to the sixth, and this would be like 1 over n to the 12th. So in the end, it looks like m to the sixth over 64 n to the 12th. Eight d cubed over 12c times c squared times d to the fourth, if I bring that c to the negative 2 power to the bottom. Eight and 12 reduce down to 2 and 3. Both can be divided by 4. D cubed cancels out 3 of the d's in d to the fourth, leaving me with just 1 d down there. So in the end, it is 2 over 3c cubed d. Questions on those three? Maybe. There's the next three. So this is going to be negative 3 cubed x to the 12th over y to the 9th. So that would just be negative 27 x to the 12th y to the 9th. Yes, ma'am. No, because it's not a negative exponent. It's a negative number, and negative numbers are okay. Negative exponents are naughty. So they get sent to the detention in the basement. Okay? Here, in scientific notation, this is really 6.8 times 3.6 and 10 to the 2 plus 8 power. Multiply the numbers together and add the exponents. Okay. So 6.8, what? 24.48. Okay. So this is going to be 24.48 times 10 to the 10th, right? Now, from your scientifical type classes, do you like that as a scientifical notation number?
No.
Why not?
Not correctly, please.
Okay. Why else don't you like it?
It's not to the furthest, so you have one number.
You gotta have one number in front of the decimal point, right? Okay. So the sig fig action would be 24, right? 24 times 10 to the 10th?
2.4 times 10 to the 11.
Right, but this step right here would be 24. Yeah.
Yeah.
Okay. So really, we'd have to move this decimal over one more. So it becomes 2.448 times 10 to the 11th power. Bad X. I concur, Kaysen, with the bad, too many sig figs, but I'm okay with it. I've made peace with it. Okay. So in this one, this is really 9.3 divided by 3.1 times 10 to the 16 minus 4 power, which is 3 times 10 to the 12th. Questions on that? The book likes to drop sig figs, or not sig figs. The book likes to drop scientific notation in here because it's dealing with exponents and all that fun stuff. Okay? Write an expression for the figure's area. Actually, I could have taken area out of that. I just wanted volume because we only gave you the volume formula. Let's change that right now. So use a formula now. Find me the area of the figures, or the figure's volume in terms of x. So using that formula, pi is going to stay pi. My radius is 2x, and that has to be squared. And then my height is x over 3. So that would become pi times 4x squared times x over 3. So that gives me a volume of 4 pi x cubed over 3. Did not have a label. One thing that I will stress to you is you need to be conscious of what the exponent is controlling. Okay? Meaning the exponent only controls that which it is directly in or directly behind or above or what is in front of it. And if that is in parentheses, then it's controlling everything inside the parentheses. If there's no parentheses, then it's just controlling what's directly in front of it, or in front of it. Okay? So, homework for tonight, due tomorrow. I will not be here tomorrow, okay? But I believe Mr. Hartwig is my sub. Okay? He'll be here. He can collect it just the same. Okay? A couple of things about it. Remember, you're doing multiples of 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. I don't know why I went to 35. We should only went to 33 there. Silly goose. Silly goose. I think on the old one I went multiples, or I went bonds. Add to a. Okay. So we'll go there instead. Okay. Second thing is, there's a couple of ones where it says tell which properties of exponents you used. Okay, you don't have to do that. I'm not so much concerned about you knowing that. You know, this property, what you did here was power to a power. You know, that part. I want you to know how to do it. Okay, and I want that to just become second nature. Okay. So Macy said we did none of the problems went on page 334, so we don't need to have page 334 in there. So this now is your assignment.